Imagine floating in a vast, empty ocean where the closest sign of life is billions of light years away. This might sound like science fiction, but it could be our reality for years. Astronomers have wondered if our Milky Way galaxy is located near the center of an enormous cosmic void, but for decades they were unsure about it. However, new images from the James Webb Space Telescope suggest that we are indeed inside a gigantic cosmic void. Scientists now believe this discovery could help solve one of the biggest mysteries in cosmology, so get ready to be surprised because what just the James Webb Telescope has found could change everything we know about the universe. The universe is like a vast cosmic web. It consists of filaments of matter, mostly dark matter, that weave together to form an intricate network. At the intersections of these filaments are galaxies and galaxy clusters, which are large groups of galaxies bound together by gravity. However, not all of space is filled with matter. In fact, there are vast regions known as voids where very little matter exists. These voids are, imagine a giant empty bubble in space. That's a cosmic void. These voids are regions of space that contain very few galaxies compared to the surrounding areas. They are like cosmic deserts, vast and empty. This discovery was unexpected and has left scientists with many questions. How did our galaxy end up in such a void? What does this mean for our understanding of the universe's structure? Astronomers have been studying the universe for centuries, but only recently have we had the tools to peer so deeply into space. The James Webb Space Telescope, with its powerful instruments, has opened up new possibilities for exploration. Historical images show how far we've come, from rudimentary telescopes to the sophisticated observatories we have today. Each advancement has brought us closer to uncovering the mysteries of the cosmos. This finding has sparked a lot of excitement and debate in the scientific community. Scientists are now re-evaluating their models of the universe. Meetings and discussions are taking place around the world as astrophysicists and cosmologists try to make sense of this new information. Star maps are being re-examined, and new theories are being proposed. The discovery of a cosmic void around the Milky Way could have far-reaching implications for our understanding of the universe. Like a giant bubble or a vast cosmic desert where there is very little matter, meaning very few galaxies, stars, or planets, these voids can be incredibly large, millions of light years across. To put this in perspective, if you could travel at the speed of light, which is about 300,000 kilometers per s, it would take you millions of years to cross a single void. Some recent studies have also found that supercosmic voids, up to billions of light years in diameter, may exist in the universe. But the kicker is that according to our standard cosmological model, this giant void shouldn't exist in the first place if it does exist. That means something is probably amiss with our understanding of the cosmos, according to a fundamental theory of cosmology named the cosmological principle, which says our universe is homogeneous and isotropic in space and time. When scientists say the universe is homogeneous, they mean that on a large scale the universe looks roughly the same everywhere. Think of it like looking at the ocean from a distance up close. You might see waves, fish, or boats, but if you look from far away, it just looks like a vast, flat blue surface. In the same way, if we look at a small part of the universe, we might see stars, planets and galaxies grouped together in different ways, but if we zoom out and look at a much larger area, everything seems to spread out evenly without any large clumps or empty spaces. So in this sense, homogeneous means the universe has a consistent composition like a smooth ocean when we look at it from a great distance. On the other hand, the term isotropic means that the universe looks the same in all directions. Imagine standing in the middle of a big, empty desert. No matter which direction you turn, the view is pretty much the same in terms of. The universe isotropy suggests that if you look at the universe from any point in any direction, you should see a similar pattern of galaxies, stars, and cosmic structures. This means there's no preferred direction in space. Everything is distributed evenly in every direction you look, so according to our standard cosmological model, if the universe is truly the same everywhere, imagine the universe as a giant sponge. This might sound like a strange comparison, but it's actually quite fitting. The sponge's structure can help us visualize the complex and intricate layout of the universe. And matter is evenly distributed across all of space and time, then the existence of a giant cosmic voids would be impossible. The cosmological principle also suggests that the universe is expanding uniformly everywhere. This means that no matter where you are in the universe, everything around you is moving away from everything else, and the expansion rate is same everywhere. But this expansion doesn't mean that the universe is expanding into something else. or that there's a center from which everything is moving away instead space. These voids are vast regions of space that contain very little matter, even less than the already sparse average density of the universe. In these regions, you might find a few stray galaxies, but for the most part, they are incredibly empty. Itself is stretching, and this happens uniformly throughout the entire universe. But is this cosmological principle right? Is the universe really the same everywhere? Well, new discoveries from the James Webb telescope show that the universe isn't as homogeneous and isotropic as we thought. In simpler terms, the universe might not be the same everywhere or look the same in all directions. The telescope has observed some distant galaxies that appear much older and more developed than they should be based on our current models. These galaxies are arranged in ways that suggest there might be significant differences in different regions of the universe. If these observations are confirmed, it could mean that large-scale structures like clusters of galaxies are distributed unevenly across the universe. Also, the discovery of a massive ring-like structure of galaxies challenges the idea that the universe is isotropic and homogeneous. If the universe were uniform in all directions, such a large distinct formation wouldn't exist. This suggests the James Webb Space Telescope's discovery suggests that they might be even more significant than previously thought. This advanced telescope has provided us with new data that could change our understanding of these cosmic voids. That matter isn't evenly distributed, and cosmic structures can vary greatly across space and time, so all this now suggests that if the universe is not the same everywhere, then there is a possibility that vast cosmic voids may exist within our universe. Our recent research suggests that our Milky Way galaxy might actually be located in the center of a supervoid, an enormous empty region in space about 2 billion light-years across. Scientists believe that the presence of a supervoid could help solve one of the biggest mysteries in cosmology, the Hubble tension. Hubble tension refers to a puzzling problem where different methods of measuring the universe's expansion give different results. A new study led by scientists Serge Mazurenko, Indranil Bank, Pavel Kupa and Morit Haslabau tries to address this problem. They looked at something called the Keenan-Barger C or KBC supervoid, a massive region in space that has fewer galaxies than usual, extending up to 300 million parsec. This area is a sort of cosmic void, and it creates a unique problem for the standard model of the universe known as the lambda CDM or lambda cold dark matter model. However, observations of the KBC supervoid don't match what this model predicts. The researchers focused on two main issues. The Hubble tension and something called bulk flow. Bulk flow refers to the movement of galaxies through space. According to the standard model, galaxies should move at certain speeds. However, new observations show that galaxies in certain areas, especially those near the KBC supervoid, are moving much faster than expected. These fast movements are surprising and do not fit well with the current model of the universe. To solve these problems, the researchers used a new approach. They applied a mathematical model developed by one of the authors, Moritz Haslabau, to predict how galaxies should move in the universe. If this model is correct, their findings suggest that if we consider this new model, the discrepancies between the observed speeds of galaxies and the predictions of the lambda CDM model can be explained in simpler terms. They found a way to make the observations fit better. With researchers around the world are using advanced simulations and observations to study cosmic voids. By analyzing data from telescopes like the James Webb Space Telescope, they hope to uncover new information about these enigmatic regions. The universe is often described as a cosmic web, with galaxies and galaxy clusters connected by filaments of dark matter. Cosmic voids are the empty spaces between these filaments, and their study can provide valuable insights into the large-scale structure of the universe. What we expect to see, their new model suggested the Milky Way may exist at the center of a supervoid. Like KBC supervoid researchers said, if our Milky Way galaxy is living inside a supervoid, you're going to see things being pulled away from you towards the more dense regions of the universe. So if you're sitting in this void, your surroundings expand faster than the rest of the universe. From this vantage point, observers would calculate a higher rate of expansion compared to what they find in the distant early universe like they do now. This study has two significant outcomes. First, it provides a new way to explain why the Hubble tension exists. it is suggested that the mismatch between different measurements of the universe's expansion rate may be due to large-scale structures present in the universe such as the KBC supervoid, and it also suggests that our galaxy may actually be at the center of this supervoid. Well, that's all for today. Hope you guys enjoy it. Before you go, don't forget to share your thoughts about this discovery in the comments. Thanks.